Okay, so hi everyone. Welcome to the session about bending space-time. Who came up with this name? I don't know what to do now.
I guess it was you, Gal, who came up with this name.
It was me. It was me. Okay, so no choice. We'll have to do some time traveling, and we'll have to do some. We'll have to fight the laws of physics. Let's see how we do with that. So, bending space-time with the help of your friends, of your peers. Let's see how peer-to-peer helps us fighting the limitations of physics. So, what you see here is Shimi, and this is Shimi in the first time he found out about peer-to-peer. Shimi, do you want to tell us anything about this picture? I think
I
it's
think
worth
it
an
was
explanation.
back in 99 or 98. First got introduced to, back then I started using peer-to-peer technology with iMesh, downloading some Unix images. There wasn't no Linux back then, or something like that.
What about music, illegal software? Something cool? Only
Yeah,
Unix?
probably that as well. Probably that's
Okay.
it. So let me introduce
I,
myself. My name is Shimi
Go ahead.
Bandiel, and I'm a solution architect at the DevOps acceleration team at JFrog.
Great. So, I'm Gal Marder. I'll be delivering the session together with Shimi today. I'm the VP of DevOps Acceleration at JFrog. We practically work together. Okay. So Shimi, obviously, we can see you were excited when you found out about peer-to-peer, and as we said back then, it was used mainly for music and maybe illegal software and other stuff that we don't want to talk about. But
Well, when
what
I
does it
had
have?
some hair.
When you had some here, and it had an amazing color. So what we want to talk about today is what does that have to do with DevOps and with serving artifacts, and let's talk about that. So let's talk about what we see today when visiting our customers, when we encounter some of the largest organizations that are practicing DevOps. So we see that there are some new challenges with CI/CD, mainly in the CD part, because since we started working with containers a lot and started using Kubernetes and started to practice cloud native, what we see is that we have sometimes relatively large images that are being served to huge clusters of runtime environments. So sometimes we see Kubernetes clusters of hundreds of nodes, and these Kubernetes clusters are very efficient in automating the deployment processes. And suddenly you release some kind of a base image or a layer that is used by many of the different containers, or something central to the application, and suddenly you have hundreds of nodes updating and downloading the new image, and this creates a type of new challenge for the infrastructure that serves these deployments.
Yeah, we see it a lot in large enterprises when there's like compliant base image, that is vetted through the process, and whenever there's an update to that, there's a burst of consumption trying to, inside the data centers, the production data centers, trying to consume that set of images.
That makes sense, and as a matter of fact, as the creators of Artifactory, high load is not new to us in any way. We've been dealing with load in many cases, but we felt that we might do something else. So what we hear is we hear about fast release cycle. We hear that our customers wants to deploy faster. Yes, Shimi.
Yeah, everyone tries to, mention the fast release cycle, trying to, shorten the lead time. And whenever they say that, what I'm hearing is always, open the floodgates.
Yeah. So these floodgates are being open, and now we have to deal with it. So obviously, we can create a large cluster of edges or artifactories to deal with the load. But as we said, we feel that this type of download burst can actually be handled better. So what's the motivation? The motivation to go with it is frequent new releases. Okay, we see those increasing over time. Everyone is releasing more and more frequently. We see large images and binaries, and again, containers is one of these drivers. And we see scaling number of customers that are consuming these binaries at the same time. Actually, are those all customers or also other types of runtime environments?
Yeah, for me, every consumer, everyone that tries to consume, the images that are distributed is a customer for me.
Okay, okay. We can agree that it's a type of customer. Anyway, when you have a central system, even if it's clustered, at some point you'll reach a resource exhaustion of any type. Okay, so we wanted to fight that. But Jimmy, let me ask you that. Distributing binaries with high scale, we have several solutions for them. So why is CDN not enough?
Yeah, so we have a CDN functionality on our SaaS offering. The problem, or why is it not enough, is because first it's it's only SaaS. So we have a lot of customers which are on-prem customers managing their own hosted environments. Even if they are on the cloud, they are hosting their their data centers there, and CDN is SaaS only. Second, CDN is aimed to serve the binaries globally. You want to distribute your software across the entire globe. CDN is the right approach. And by the way, it shouldn't be like P2P versus CDN. What you can do, and we later see with edges how you can combine the global and local approach. But if you compare P2P versus CDN directly, so CDN is more of a global approach where you don't have real artifactories close to the consuming points. With P2P, we try to solve bursts, consumer bursts locally in the same data center usually. And as we will see, P2P handles bursts much better and faster than CDN. Because a CDN, if I want to have my data center with hundreds or maybe thousands of consumers try to download an image, the CDN will provide that image very close to that geolocation, but still the laws of physics, there's so much a single endpoint can take regarding download bursts.
Okay, Shimi, we'll go P2P. That's okay, but I guess that's also answers the answer for why not edges. So I would say that edges are great. They provide us with great control and an atomic, reliable, and efficient way of moving things closer to the runtime environment. But at the same time, just like CDN in that case, they focus on something different, and they do not handle bursts as well as P2P, because there's this central edge that serves the entire data center or the entire location. Again, it can be clustered, but still it's central, and that's why it will never scale as a P2P technology.
Agreed. Yeah.
Okay, so how do you kind of picture the massive Docker pool in the P2P environment?
Yeah, so as you can see here on the left side, you have the traditional approach where the binary is the artifact, let's call it a Docker image. The Docker image is being pushed from the CI/CD process into the Artifactory, or in our case, let's say the edge in the data center. And then you have a massive amount of clients, Docker clients, trying to pull that image. And as we scale the number of clients, we will reach resource exhaustion on the edges that we try to pull from. In the P2P implementation, what we see here is that the peers that stand between the edge and the clients, and these peers are local processes that are running on the same client's machines. The peers will communicate between themselves to transfer pieces of the image and the layers in order to to flatten the bursts and make the network usage much better and faster. So in classic peer-to-peer technology terms, the peers are the ones that are serving as in this case as the Docker registries that the Docker clients access. They are themselves not Docker registries, but they know to handle the download by first contacting the Artifactory or the edge node, which serves as the tracker in the P2P technology. The tracker is the one that is responsible for having, the full view of who are the peers, maintaining the peer list, their statuses, and the files that are available. So Artifactory or the edge is the tracker, and we have specified processes running on the machines that are the peers, and then the clients are the regular Docker clients or curl, wget, native download clients that for generic repositories.
Okay, so essentially the clients are the same clients. Okay, they kind of connect directly to the peer that they see as the registry, and Artifactory itself is both like the initial seeder and the tracker for the whole swarm.
That's correct? Yeah,
okay,
definitely.
Cool. So what do we currently support?
So currently, what is supported are the most common use cases. It's Docker registries, handling bursts of Docker images and layers, which are usually large files, large artifacts. So the first implementation of our P2P will support Docker repositories as well as generic repositories, because we see still a lot of large enterprises and a lot of use cases where the consumption is in data centers is of large tarballs, ISO images for VMs, a set of machine learning models and data, and very large files that are stored in generic repositories.
Yeah, we definitely still see those on customers. There are legacy applications that started before someone even thought about Maven or anything that manages
or cloud native. Yeah,
exactly. So those should be served as well, and I think generic is maybe very useful for that. Okay, so the different P2P protocols out there. Torrent probably the most well-known one, and we did decide to write our own. And what was it that guided us to write our own protocol, and what's there under the hood?
So essentially, we will see it when we'll go into some implementation details. What we want to leverage here is leverage the fact that we have an Artifactory as our tracker and initial seeder, serving as the source of truth. And we'll go about that in the next slide. What I do want to mention here is the solution is very low maintenance, because the peers themselves are very simple processes that you install on the nodes, on the client machines. It is very optimized for internal use, intra data center communication. And as I mentioned, Artifactory is serving as the source of truth. All authentication, all authorization is going, as usual, through the Artifactory or the edge node.
Okay. So let's see how we achieve this. So what's under the hood there? What's going on?
Okay. So first, Artifactory or the edge node is the source of truth. It means that if you delete the file in Artifactory, for example, even if the pieces of the file or even the file itself is available at the peer or at neighboring peers, you will not be able to download that, because every request first goes to Artifactory to validate, to get the actual view of what's in my system. Second, the communication to the tracker is based on gRCP, which is a very friendly protocol. Intra and inter-peer communication is encrypted over TLS. There is no hash ring, or this mail is mentioning that the peers themselves, they don't hold a lot of metadata. Peers don't try to communicate each other for discovery or trying to learn about other peers. All of this type of communication is going to the Artifactory, to the edge, to what we call the tracker, and the communication between the peers themselves is only for downloading. It makes everything much more simpler and much more secure. And Artifactory is serving as the tracker, the edge node serving as the tracker will handle the download plan to the relevant peer asking for it.
What else can you tell about this protocol?
Yeah, there are several more very important features. First one being it supports streaming. So the main idea here is we have imagine a sliding window. Let's say I want to download a file which is split into 100 pieces. So let's say I'm getting created. The P2P implementation creates like a sliding window starting at the beginning of the file. And then let's say the peer will try to take a piece out of the first 10 pieces of the file. So we'll have like a sliding window that the peers randomly start to consume, and the sliding window rolls down, meaning that when the client try to download the file, they will very fast start getting the beginning of the file. Essentially, we start streaming as soon as possible the file. We try to resolve the download from the beginning or very close to the beginning. And that means that the peers don't have to like cache or maintain the entire file. They can start streaming it very soon, which will lower pressure on resources and make the consumer available to start to use that faster. Moreover, we do double checksum verification. It means that the P2P implementation will verify with checksum both the pieces and then after that the entire file. We can disable the second verification if we want of the entire file. By default, it will verify twice because we don't want to get something that wasn't intended or was tampered with. And the last thing is the P2P is working with tokens. So if I want to download the file, I need to get a token from the tracker, from the edge node, from Artifactory. I need to get a token as this token is specific for that file only. So even if I got a token from someone that I wasn't authorized to do, and I got the token, I cannot download any other file that, is not associated with this specific token. It's very secured and very safe.
Okay, so what I hear is that this protocol has practically enabled us to do two things. First of all is to make sure that, unlike when you downloaded music back like in 20 years ago or probably more, then the client was actually writing directly to the disk where you want to store it, and you did not really care about the order unless you really wanted to stream it. Here, the client or the peer is actually a mediator between the source and the one who wants to download the file. And in that case, you have to download for the peer as well. So being able to kind of start downloading from the peer before the peer got all the pieces is very important. And also for resources, not having to have the peer store everything, the full artifact. That's one thing. And the second thing about the tokens is that we practically managed to extend the security model. So the same permission model that we have on the edge is going to serve us also on the peers, and we can enforce that with using those tokens. I think that this is very powerful, and it couldn't be achieved with the standard peer-to-peer protocol. So that's cool. Okay, so as you know, JFrog and the JFrog platform starts much far to the left than the deployment of the actual artifacts, the actual runtime packages into the runtime environment. And I wanted to kind of take a moment and show you where does this all fit in. So you're probably all aware of Artifactory, and Artifactory has started by serving developers, serving third-party dependencies, controlling them, serving them to the developers, serving as a facility to share binaries between developers and to serve our CI processes. So the way we see the full flow is that, yes, you start your CI very early in the CI, you have your first binaries those binaries are stored in the Artifactory. Now, throughout the CI, those binaries are being promoted from one repository to the other to kind of follow the stages of your CI and software development lifecycle. Obviously, these stages will include security scanning, which should be continuous, and that's where X-ray come into the picture. And eventually, you want to start your distribution process. Distribution is kind of the start of the journey of those binaries from the development environment to the runtime environment. And this journey starts with our distribution service that allows us to define what we call a release bundle. This release bundle is a logical atomic grouping of the different artifacts that compose a release. It may be, I don't know, several Docker images, for example, in a Helm chart, and maybe some other types of artifacts. And then I want to distribute these binaries or move them in an efficient way to the edge nodes, closer to the runtime environments. And this is what distribution does. It takes those binaries and atomically, securely, reliably, and in a very efficient way, moves them from my development environment to the edge nodes, which reside on all the runtime environments that I have. And then from those edge nodes, until this point, we kind of took we fetched these binaries directly to the runtime environment. But what we saw is that for very large set of servers that are trying to update automatically the same version at the same time, this becomes a challenge. Those bursts that we see for large organizations really becomes a challenge. And this is exactly where peer-to-peer perfectly fits into the picture to make sure that on the edge, we are completely scalable. And even if we have hundreds of downloads at the same time, we kind of keep being performant and serve our customers in the best way possible. So what we see here is an actual download benchmark that we've done. What you see in the x-axis is the number of peers, or in other words, the number of nodes, runtime environments that are fetching the artifacts. And what you see on the y-axis is time, okay, the median download time for these amount of artifacts that we try to download. And what you can see very nicely that up to a certain point, there is no significant difference between peer-to-peer and downloading directly from Artifactory, because Artifactory is a very scalable solution, and we can actually handle a lot of load. But at the same time, every central architecture at some point, at some load, will exhaust the resources. And that's where we'll start to see the degradation that you see when we have more concurrent clients that are trying to download. On the other hand, you see a very nice flat line of the time it takes peer-to-peer to download. And this is the magic of the peer-to-peer architecture, that the more concurrent downloads you have, the more power you add to the facility that helps the download. So you kind of get to stay on this flat line that doesn't increase the time of downloads. So this means that in our architecture we have now a new component, and obviously the way peer-to-peer works, we're gonna see many of them. So how are we gonna manage and administrate that, Shimi?
So what we see here is essentially, as I've said before, the edge node or the Artifactory is serving as the tracker. So you can see on the large image the information about the peers. So the edge node is holding, the entire peer list, with their statuses, progress, addresses. So we get a comprehensive view about, what is going on in the system from visibility point of view. And on the smaller image, you see, remember the tokens we mentioned. So you can download the P2P token that you will provide your peers, and this will identify the peer itself, and the peer will be able to access the tracker and then request a download, get a specific token for that file, and with that token will be able to access other peers and download the file. Okay. And by the way, it's not only UI, you can get, everything through REST API as well, as with all of our features and abilities. You can automate everything.
Obviously. Okay, so just a short summary before the demo. So we promised to kind of fight the laws of physics. I hope we did. We had some time traveling. We saw Shimi excited about peer-to-peer. That was an experience for me at least. I hope for you as well. We also saw that we can actually kind of break the laws of physics with you saw the graphs. You saw how we tackled this. So obviously peer-to-peer is not a new technology in general, but the use of peer-to-peer for DevOps and handling the load of deployments and connecting peer-to-peer with the consistent model of CI/CD is new. And what we're going to show you right now is a live demo of the system running. So bear with us just a few more minutes to take a look at this demo. So Shimi, to you.
So what we see here is first, we have set a single Artifactory node. You can consider it an edge node in your data center. And we have multiple consumers try to download the file. It's 100 megabytes file. And you can see, it's progressing, and we will see that compared to 40 peers that try to do that simultaneously. So now we are starting to do that with 40 peers and do it in the P2P fashion. So let's start all the peers in the Kubernetes demo environment. It will take them a second to start. So 1 second. Let's see. So you can see here in the status that the containers for the peers themselves are starting to run. And in a second, you will see the download of the components here. Everyone is okay. So now let's perform the same download. And there's a lot of tracing messages here, as you can see, for the communication of the pieces between the peers. And you can see that, we are leveraging the network much, much better than, a single central resource we try to access. The main difference in times will be here about 2 times. It's not like 100 times faster, but it's a bit faster. We are talking 40 peers here, and not hundreds or maybe thousands of peers. As we will increase the number of peers, what you will see is you see dramatic improve over the single edge node that everyone is trying to access. So now bringing down the peers, and this is it. This was peer-to-peer. Thank you very much for the session.